We can classify covalent bonds according to how well the participating atoms are sharing those actual electrons. So we have two different types of covalent bonds when we start to classify them like this. We have nonpolar covalent bonds, and then we also have polar covalent bonds. And so the nonpolar covalent bonds, these we define as the covalent bonds are formed by atoms that are sharing the electrons equally. So, for example, if we happen to have a tug-of-war contest, and I have my two people here, and they're both trying to, if this is my little rope here, and you have that knot in the middle, and they're pulling back and forth, if they are equally matched, so one is just as strong as the other, notice that that knot stays pretty much right in the middle. That's what we're talking about for nonpolar covalent bonds, because when we're talking about the sharing of electrons, you're going to have an atom here and you've got an atom here, and if I just draw part of the picture, they're sharing this pair of electrons. So each one is sharing one electron with the other atom, the neighboring atom. And if they both have an equal kind of pull on those electrons that are being shared, those electrons stay right in the middle. So that's what we classify as a nonpolar covalent bond. Now, when we switch gears and we start talking about the polar covalent bonds, now it's a little bit different, because the polar covalent bonds, this is when we have a covalent bond formed by atoms that do not share the electrons equally. Okay, so if I was to go back to my tug-of-war picture, this would be represented by having a small guy, and we have this really large, stronger guy over here. And so when you have a tug-of-war between the two, we assume that the bigger guy is going to be winning here. So notice that the knot now is shifted over towards the stronger, bigger individual. All right, so when we draw this as far as our covalent bonds actually look, I'm just going to write A and B for the names of my atoms here. And so if we assume that B is the bigger one, B is going to be sharing electrons with A, but B is going to be pulling those electrons a lot closer to itself. So notice that we're no longer sharing the electrons right down the middle of the two atoms. Instead, they are getting shifted to one side. Now, the reason we have these differences in how well the electrons are sharing the atoms does have to do with strength of the participating atoms. And what we're seeing on this table is what we call, this is an electronegativity periodic table. And so electronegativity, this is this property that atoms have, which we can kind of generically describe as the strength of an atom for the surrounding electrons. And that's exactly what these electrons that are in these covalent bonds are going to be. So some of the atoms are going to be stronger than others, or some of the elements are going to be stronger than others. Now on this table, it does a nice job of just shading some of the different elements so that we can quickly see which ones are fairly comparable to each other. So all of the green ones, for example, are quite close in electronegativity, so they have been shaded in green. And the ones that we're going to focus on are carbon and hydrogen and oxygen and nitrogen. And the reason we're really going to be zooming in on those four elements is because those four elements together make up about 96% of living matter. And so they are going to be ones that we're going to see many times throughout this semester. Well, notice in this picture that hydrogen and carbon are both being shown in yellow and indicating that they are relatively equal in their electronegativities. And just the same way, nitrogen and oxygen are both being shown in purple here, indicating that they are relatively equal. When you compare the carbon and the hydrogen to the oxygen and the nitrogen, carbon and hydrogen are relatively weak, and oxygen and nitrogen are relatively strong. So that right there is going to be a very important thing for us to remember when we start to look at different covalent bonds, and we want to classify them then as being polar covalent bonds or non-polar covalent bonds. So let's look at some examples. Whenever we start looking at these examples, we do have to keep in mind what we just drew on the previous picture, and that is that carbon and hydrogen are going to be relatively weak, and oxygen and nitrogen are going to be relatively strong. So if we look at a common example here, this molecule would be what we call methane. This is a carbon atom that is sharing electrons with 4 different hydrogen atoms. So we see 4 single covalent bonds. Now, if we want to know whether each of those covalent bonds is polar or non-polar, we need to look at each bond and we need to identify the participating atoms as being either weak or strong. So if we look here, hydrogen is weak, so I'm just going to write weak next to each one of the hydrogens. And then carbon is going to be weak as well. So notice that when we look at each one of those bonds, the atoms that are participating, they're going to be relatively equal in their strengths or in their electronegativities. So what that means is that those electrons are going to get shared right down the middle. And I'm just going to draw those electrons on here so that you can visualize better what we're saying. So this is, in this case, all 4 of the bonds are exactly the same, and these are going to be non-polar covalent bonds. Again, because we are sharing equally. Now, that's not always going to be the case. So if we look at another example, if we go back to our water molecule example, here we have water, and we're going to do the same thing that we did before. We're just going to go through here and identify each one of these atoms as being either strong or weak. Oxygen is strong, but the hydrogens are weak. Okay, so I write that on there, and now I want to go through and think about where those electrons are going to be. So if my oxygen is very strong compared to the hydrogen, those electrons are going to be a lot closer to the oxygen atom. And that would be the case for each one of these bonds. So in this case, now we are looking at what we call a polar covalent bond, and we are not sharing equally. Ultimately, what this means is that we are going to be shifting some charge around these molecules. So if we happen to have extra electrons on this side of the molecule, that means we have extra negative charge on this side of the molecule. So we end up with one area over here. I draw it in another color. Over here around the oxygen, we have extra negative charges. And then over by the hydrogens, because we have somewhat pulled away part of the negative charges, we're left with a little bit of extra positive charges. So whenever you have these polar covalent bonds, we end up with what we call a separation of charges. In other words, we get areas that are a little bit positive and other areas that are going to be a little bit negative. And that's what we have with the water molecule. If we look at just one other example here we have, I'm going to put a carbon, hydrogen. This is obviously going to be a larger molecule than what we've looked at so far. And so we have a lot of different covalent bonds here. They're all going to be single covalent bonds in this case. And if we wanted to go through and identify each one of those covalent bonds as being either polar or nonpolar, again, we first have to think about whether the participating atoms are strong or weak. So in this case, the hydrogens are weak. And again, this all goes back to this right here. So you really should memorize that. The carbon is also weak, and then the oxygen is going to be my strong one. So if I think about where those electrons are going to be at, if they're being shared between two weak ones, they would be right in the middle. And that is the case in each one of these bonds. However, when we look at this bond between the carbon and the oxygen, now we have a strong one with a weak one, which means that the electrons are going to be much closer to the strong one, which happens to be oxygen. And then down here with the oxygen and the hydrogen, we have the same situation where you have them shifted closer to the oxygen end. So if we were to label these as polar or nonpolar covalent bonds, we've got these three right here, which are all going to be nonpolar. And then we've got two down here, which are going to be polar covalent bonds. Notice it's very possible for a molecule to be made up of a mixture of nonpolar covalent bonds and polar covalent bonds. Another thing we want to be able to identify is where we're going to have those little areas of positive charge and little areas of negative charge. If we look here, the extra electrons are around the oxygen. So that's where I'm going to have a little bit of extra negative. And then the extra positive is going to be around the weak ones that are participating in this polar covalent bond. So there I've labeled where I have my positive areas and where I have my negative areas.